Hello, it's me, and I'm going to fulfill a couple more requests actually. One of which was to continue the Back to Basics series where I just kind of go through the solve strategies, starting off with a two-layer series, the 2x2 series. Now remember that to solve this puzzle, all you needed were two algorithms. Well, one algorithm, one commutator. So you have the orientation issue, which is solved by the RIDIRD, and then you've got the permutation, which is moving one piece to the next using the corner swap. 2RU, 2RUI, 2R, turn, 2RUI, 2RU, 2R. Anyway, so that's all review from last time. So again, orientation is when you have to rotate this, which is RIDIRDs, and permutation is when you have to take a piece and move it from one place to the next. And using just those two algorithms, we're able to solve a variety of different types of even-layered, two-layered puzzles, but any even-layered puzzle can be solved like that. So what happens when we start to add different components to a puzzle? So here, these are all corners. And things like 4x4s or other even layer puzzles are different variations of corners. But what happens when we add true other pieces? For instance, in this 3x3x2, we've got our corners here, but we also have centers and edges. So the most basic of three-layer puzzle, odd layer puzzle, will be the 3x3x2. Yeah, there's other three-layer puzzles out there like the 3x3x1, but honestly, this doesn't really get into the solve strategy of what to do about edges that get scrambled into other layers. If I were to define what a center is the piece that goes down, well, to the core of the puzzle and really just rotates. It doesn't scramble really with anything, it just kind of rotates around. A true edge piece is something that has corners on both sides. So an edge piece goes down to the center and has two corners on either side of it. Here, there's actually an edge piece in here, but it's down hidden. It's hidden deep in here. Every corner piece has to have something that it slides across. In this case, that's going to be an edge piece that you can't see. If you bring out the edge piece, you've got a odd layer puzzle. So in order to solve this, just like with the corners, we're going to have issues with permutation and issues with orientation. In other words, issues with rotation and issues with moving it around. Do we need to rotate it or do we need to move it around? So what I need to do in order to move these guys around is I need to add, well, another algorithm. Actually, two algorithms. It's really one that has two different subsets, but they are done differently. So just by navigating these edges around, we need to add edge permutation algorithms. So just by demonstration, now as you know with this 3x3x2, or if you didn't know, I'll tell you now, according to the law of cuboids, because this is an even layer, this is an odd layer here moving into an even layer, when you turn 90 degrees, you can't turn 90 degrees beyond that, because this edge piece is now lined up with a hidden edge piece underneath, but is butting heads with these corners, so you can't make another turn like that. So we'll just continue to do scramble over here. Now, even though this has a two-layer component, I'm going to call this the most basic of the odd layer puzzles, because truly it is a three-layer puzzle, even though you're two layers down here. This hidden layer here really doesn't enter into the scramble or the solve too much. Okay, so what do we do about edges? We know what to do about corners. What do we do about edges? So to solve this guy, what I'm going to do first is I'm going to put the edges in. So anytime you have a puzzle that has edges, deal with them first, most of the time. Anyway, you've got this one in here. This is the green and yellow. So which is the one that comes next to it? Well, I can use these corners to help orient that. So here's a green corner over here. I'm just going to move that in. So this green corner, if it's over here by the center, I know that the red is going to be just to the left of it, which means that I'm going to put a red edge over here. So the red and yellow. Find it, and it is right over here. It's on the wrong side. So I'm going to bring it down, simply move it underneath in place, and bring it up. So now what goes next to the red? Well, if green goes next to red, is it yellow, or rather is it orange, or is it blue? Now, if you memorize the color scheme, then you'll know what it is, but just in case you don't, then you can once again use a corner to decide. So moving it around, I can move this into here to see the green. The orange goes over to here. So if the orange goes here, I'm going to find the orange one, orange edge, bring it into here. There's only one more left, and that's the blue. Now over time, if you haven't, you're going to kind of get a feel for what goes opposite what. Red opposite orange, green opposite blue, yellow opposite white, but that doesn't happen with every kind of cube. It's just the standard color scheme. So now what I'm going to do is I'm going to handle corners the same way I handled it here. But in this case, orientation is never going to be an issue because I couldn't do an RIDI move. If I can't do an RIDI move in the scramble, then I don't need to do an RIDI move during the solve, which means orientation or rotation is never an issue. So all I have to do is move it in. Now I'm going to delineate a technique that I kind of hinted on last time, but I think I need to delve further because we're going to start getting into more complicated puzzles using these very simple techniques. And that's what I'm going to call the swing up technique. It's not an algorithm, it's not a commutator, it's a strategy. So I don't count that as something you really need to specifically memorize. So the swing up technique is where you find what's supposed to go here. And in essence, all you're going to be doing is 2R, 2L, 2R, 2L. Now you might think, I didn't do anything. Nothing really changed. I just turned this, then turned this, then turned this, and then turned this. But what I'm going to add to this is I'm going to add the swing up move. The swing up is where I swing the up move back and forth in between all of those two R's and two L's. By swinging that, I'm going to cause corners to move in specific places. There is another way to swap corners and to move that using 2RU, 2RUI, 2R. I'm going to abandon that for now. Just because we might not need to use that. Because to do that causes certain placement parities or misplacement of other layers. So what we're going to do is find what's supposed to be here, and you're going to be taking your U move, and if you start off with a 2R, you're going to swing the U so that the piece that you moved swings to an L position. Then you're going to swing it back to an R position, swing it back to an L, each time doing your two L's or two R's. So let me demonstrate. Let's say I'm looking down here, I see the green and the orange. Where does that go? Well, here's the orange, here's the green, so it goes over here. You can see this is the wrong one. We're going to position this just below to where a 2R will place it into this position. So I'm going to do my 2R, 2L, 2R, 2L. Each time between each move, swinging my up vote, so to speak, swinging my up move, whether it's a U or UI, so that it goes to the other area. It goes from R to L and then L to R. So I'm not even going to tell you if it's a U or UI. You're just going to swing it to where it's going to go from the R to the L. So this over here, we do a 2R. Now we're going to swing this piece to the L position. So we're obviously not going to do a U because that doesn't swing it to the L position. It stays in the R. So we're going to do a UI, but don't memorize that it's a UI. Just know that you swing it to the L, then do a 2L. Now swing it back to the R position, do a 2R, and swing it back to the L position and do a 2L. And you'll find that it's placed quite nicely. That's all it is. So let's try some more like that. Down here is red and blue. Here's the red and blue spot right here. So move this down just below where it's supposed to be. It's going to be below and across. Do 2R, swing the U to the L, 2L, swing the U to the R position, 2R, swing the U to the L, and then 2L. And that's placed. So now we've got this. I'm looking for the yellow, the orange and blue. Orange and blue, where are you? It's right over here. So that's already placed here. 2R, swing it to the L, 2L, swing it to the R, 2R, swing it to the L, 2L. And now that's placed. So we're getting there. We have one more to go. Place it over here. 2R, swing it, 2L, swing it, 2R, swing it, and 2L. And then you've got this whole side done. So everything is done over here. So far we have done 0 algorithms for the first layer. Now for the second layer, I'm now going to fall right back into doing the corners. I'm going to place the corners in exactly the same way that I placed it with every 2x2 thing that we saw. So to do that, find, with that technique, remember we found the 2 corners that are in, and these 2 are in. I'm just going to line it up to the proper place here. And now we do a corner swap. Don't worry about the edges yet. That's going to come. We do the same algorithm, nothing new. 2RU, 2R, UI, 2R, turn 90 degrees counterclockwise, 2R, UI, 2R, U, 2R. And then what that does is you can see that all of our corners are placed. Now it's a matter of edges. What to do about edges? Well, there's two variations of moving edges around or permuting edges. And that's going to be if they're adjacent and need to be swapped, or if they're opposite and need to be swapped. You can see here that this is adjacent. So we're going to introduce our first edge turning algorithm of an adjacent edge swap. So an adjacent edge swap is going to swap these two. Now you're probably thinking, well, wait a minute, is that going against the law of cubes? Because if I swap these two, shouldn't that also swap something else? Because I'm just doing a single swap. According to the law of cubes, you can only swap an even number of times. I can't do an odd number of times, so this is one swap. In other words, what's supposed to happen is, let's say I just borrow this here for a second, and let's say I want to do the same thing, I want to swap these two, something else is going to have to be swapped. In this case, it's going to be these two are also going to be swapped. But I'm not going to worry about that because this is even layer here. Hidden underneath here is a hidden layer, a hidden edge piece. That is going to swap, but we don't care because you can't see it. It doesn't participate in the scramble or the solve, but it's there. It's only when you pull it out to make a 3x3 that it's going to become an issue. But for now, for the 3x3x2, it's not an issue. So for illustrative purposes, to swap these two, that algorithm is 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R, and it swaps them. It looks like it went against the law of cubes, but it didn't because there's some silent action underneath that had occurred. So that's the opposite, that's the adjacent edge swap. Sometimes you get a situation like this. Although it looks like there's another issue here, this is okay, but these opposite areas need to swap. So then we introduce the concept of an opposite edge swap. An opposite edge swap will do just that. It'll swap these two. And that algorithm is 2R, 2U, 2R, 2U, 2R, 2U, and it's done. Now, you're probably going to find a situation where you've got a whole bunch of edges that are out in a very haphazard way, like this. So you finished your corner placement and you're doing fine, and you see that none of these edges appear to be in. Well, that's okay, just swap what you can. What I'm going to do is, it's not going to be an even swap here. I can't do anything that'll swap two to go in exactly the right place, but I can put one in the right place. I can swap these two and put the red one to here. It will put this orange one out where it needs to be, but we can work at things one at a time. So we do an adjacent edge swap, 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. That's in, and we've got these three to deal with. So we're going to do, well, we can do an opposite edge swap to get this blue to here, 2R, 2U, 2R, 2U, 2R, 2U. Notice that's a pretty easy one to remember, and that one goes pretty fast. That's going to become important later. And now we just do an adjacent edge swap over here. This one is also pretty easy to remember as long as you, well, if you do it enough times. The pattern actually is kind of flows pretty well. That's 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2RUI, 2R. So this is a cute little puzzle to take around with you. It really doesn't require a whole heck of a lot. All you need is that one corner swapping algorithm. You don't even have to do RID, RD, so it's just three algorithms, one of which is a corner swap, which you've already seen. The other is the two edge swaps, adjacent edge swaps, and opposite edge swaps. So that covers that. Now, what if we were to pull this up to the 3x3? Now, here's the thing. I'm going to bypass this. Why? Because the internet is buzzing with tutorials on how to deal with a 3x3. And the last thing we need is yet another tutorial on what to do about this. So what I'm going to do is I'm going to issue a challenge. Most of you who are watching this probably know how to do a 3x3 and probably have your favorite method. If you don't, well, that's okay too, because here's my challenge. For you advanced solvers who had to sit through yet another solve of the 3x3x2, my challenge is this. Solve this layer by layer, but not this layer and this layer. Solve it this layer, then this layer, then this layer. So you're going to put this side in, then you're going to put this side in, and then you're going to put this side in. So you're going to have to use algorithms that I've not talked about. So for the advanced solvers, that's my challenge to you. My next challenge is to solve the 3x3 using only the algorithms that we've covered in our Back to Basics series. What that means is only use the 3 algorithms and 1 commutator, or if you want to say 4 algorithms. The 2 corner strategies of doing RIDA-RDs and the corner swapping algorithm, and now just those 2 edge swapping algorithms, the adjacent edge swap and the opposite edge swap. So my challenge to those that have been watching from a beginner standpoint, you now know all that you need to know to solve the 3x3. This iconic, original puzzle that's been in the hearts and minds of the public for so long, among the original twisties, not the original, but among the original ones. Go ahead and solve it like that. And my challenge to those advanced solvers, don't use the beginner's method, don't use any of the other methods that we're talking about with many, many different algorithms. Solve this just using those 4 algorithms. And I'll tell you, you may run into some trouble when you end up with the last layer and you have to orient the edges. There is a way of doing it using exactly the same algorithms. So that is my challenge to you.